Okay, as I mentioned before, today we're going to get into simple machines and how they work and how they give us an advantage, a mechanical advantage. As you can see here on the screen, there are 6 different types of simple machines that we'll be going over in the next few lessons. We'll cover 3 of these simple machines today, and then on next Tuesday we'll cover the other 3 types of simple machines. So what are the types of simple machines? The first is what we call an inclined plane, a ramp. The second is a screw. A screw is a special type of inclined plane that wraps itself around a cylinder. Then we have a wedge, which is basically 2 inclined planes put back to back. We have levers, which there are 3 different types of levers. We'll get to those later at the end of the lesson today. A pulley system, as you can see here, and then we have a wheel and axle. And a pulley system actually use a wheel and axle in its setup. So those are your 6 different types of simple machines. The first type of simple machine we're going to focus on is pulleys, and in your next lesson on Thursday you're actually going to be doing a gizmo with pulleys, so make sure you're paying attention to this part or review it before your gizmo. So, what are pulleys? As I mentioned, pulleys are wheels and axles that have a groove around the wheel. What's the purpose of the groove? That allows you to add a rope, chain, or belt so that you can pull on the pulley, okay, and make it work. So a wheel and axle with some type of rope, chain, or belt to help drive it is what a pulley is. Now, there are different types of pulleys, and we're going to go over those different types of pulleys, 3 different types of pulleys here that I'm going to mention. The first of those is simply what we call a fixed pulley. In a fixed pulley, the wheel and axle is set in place, or it is fixed. It does not move. Okay? What does a fixed pulley do for you? It changes the direction of the force. You can see here in the particular pulley system, you pull down on the rope and that'll lift the object you are wanting to get up. Now, what is the mechanical advantage of such a pulley system? The mechanical advantage is 1. You really don't gain an advantage. Your advantage, I guess you could say, is the change in direction. It might be easier to pull downward as opposed to push upward. Okay, so remember we talked about force in and force out, and if those 2 things are equal, we get a mechanical advantage of 1. So that is the case with a fixed pulley. The second type we have is what is called a movable pulley. As you can see here, when the rope is pulled, the pulley rises along with the object. Okay, so the pulley or the wheel and axle is movable. Okay, to calculate the mechanical advantage of a movable pulley, it's quite simple. All you have to do is count the number of support ropes that are involved. In this particular case, you have a rope on the left, a rope on the right, a mechanical advantage of 1, or excuse me, a mechanical advantage of 2. Okay, so that is a movable pulley. And finally, our third type of pulley system is what we call combined pulley. Many people call this a block and tackle. Okay, and a combined pulley, usually you will have 1 fixed pulley and a series of movable pulleys. That can either be 1 movable pulley, 2, 3, and so on. Okay, to calculate the mechanical advantage, you just calculate the number of pulleys. Really, you're calculating the number of wheel and axles involved. In this particular case, we have 2. So this pulley system would give us a mechanical advantage of 2. You would have to pull with half the force of the object you are trying to lift. The disadvantage of using a combined pulley is you are going to have to pull this over a longer distance. Okay? In other words, if you pull the rope 3 feet, the object is only going to rise 1.5 feet. Okay, so if you need to raise it 3 feet, you're going to have to pull the rope 6 feet. So again, that's a slight disadvantage, but we often use these when we're trying to lift something that is very, very heavy. This is a combined pulley system. Okay, so 3 different. We have our fixed, we have our movable, and then we have our combined pulley or block and tackle. Okay, let's move on then. Incline planes. Incline planes. What is an incline plane? A surface that is higher on one end than the other. All of you know what a ramp is. All of you already know what an incline plane is. Okay. So how does an incline plane work? It makes the work of moving things easier by increasing the distance a force is applied. Okay. By increasing the distance, okay, you can apply less force, therefore makes your job easier. Okay, as you see the guy rolling the barrel up on top there, it is easier for him to push the barrel up the ramp than it is to grab the barrel and lift it directly. Okay, up onto the stand. So this makes his work easier. Now, how do we calculate the mechanical advantage of an incline plane? It's actually some very simple math. Don't get too worried. The ideal mechanical advantage, and again, remember we're dealing with no friction here. Obviously that's not the case, but we're just going to assume it is. And all you have to do is take the length of the slope. You can see in this picture that happens to be 15. And divide that by the height of the inclined plane. How high do you want to go up? In this case, the inclined plane goes up a height of 3 feet. So this particular inclined plane has a mechanical advantage of 5. It's simply the length of the ramp divided by the height of the inclined plane. Okay, that is its mechanical advantage. And that leaves us with our third simple machine of the day, and that is the lever. There are 3 types of levers. One type here, as you can see, is what we call a first class lever. Here is your second class lever, and finally your third class lever. Now if you look closely, you have to pay attention to where is the fulcrum. That is what is labeled F. The effort, that's where you apply a force, and the resistance, that is the force out, okay, or what you are trying to lift. Now you'll notice in each case, each of the 3 levers, okay, the position of the fulcrum, effort, and resistance is different. So this gives us different types of mechanical advantages here. So again, 3 parts to every lever. The fulcrum, this is your point of rotation. The effort arm, that is the distance from the effort force. You can see in this case the red arrow, the E, to the fulcrum. And finally the resistance arm. This is the distance from the load, or the resistance, to the fulcrum. Okay, and you can see in each case that those are different. So mechanical advantage. How do we calculate the mechanical advantage of a lever? It is a ratio. Okay, so again, we are dealing with a division problem. Anytime we're doing ratios, we are dividing. So you take the length of the effort arm. Again, the length of the effort arm is the distance from the fulcrum to where the effort force is applied. And you divide that by the length of the resistance arm. Okay. So let's look at our first class lever. The fulcrum is always in the middle. This is the only lever in which the fulcrum is in the middle. This would be the same as like a teeter-totter. Okay. You can see in this picture that you are best off You are best off by having the fulcrum closer to the resistance. The effort moves farther than the resistance. This multiplies the effort force and changes its direction. So what do I mean that multiplies the effort force? It's going to take you less force to lift the weight of the object. You're going to have to apply less force than what the force of the object is. The longer your effort arm, the less force you have to use. Now the only problem is you're going to move it, the more you move the fulcrum towards the resistance, the shorter the distance the object is going to move. First class levers include things such as crowbars, scissors, pliers, tin snips, all those working the same way. As I mentioned, seesaws or teeter-totters. All these are types of first class levers. Okay. If you take a screwdriver to open a paint of can, you're actually using the screwdriver as a lever. So all of these are ways that first class levers work. Let's move on now to our second class levers. In second class levers, we have the fulcrum on one end, the resistance in the middle, and the effort on the other end. Okay, again, the fulcrum is on one end, the resistance is in the middle, and the effort is on the opposite end. What does this do? The effort must move farther than the resistance. This multiplies the effort force, but does not change the direction. Again, to calculate the mechanical advantage, whether you're doing a first, second, or third, you simply take the length of the effort arm and divide by the length of the resistance arm. The longer your effort arm, the better off you are. Second class levers. Nutcrackers, as you can see pictured there, wheelbarrows, doors actually are second class levers. Bottle openers work as second class levers. Okay, you have your fulcrum on one end, you apply effort on the other end, the resistance is in between. Okay, third class lever, you can see here what we've done is we have switched around the resistance and the effort. Okay, now the effort is in between with the fulcrum on one end and the resistance on the other. This does not multiply force. You do not gain any advantage here. Actually, probably makes it a little harder. Resistance moves farther than the effort, so this multiplies the distance. That is the advantage of using a third class lever. If you were to calculate the actual mechanical advantage, you'll know that it's going to be less than 1. However, you do gain a lot of distance here. So even though you're pushing harder, you do get it moved over a greater distance. So sometimes we have to use this type of lever. Whether you guys realize this or not, you do it all the time. We have hammers when you're trying to pull the nail out using the claw, tweezers, shovels. Your arm acts as a third class lever. You putting something in your hand and bending your arm acts as a third class lever. So as I said, you use this type of lever all the time with your arms. I'm sure many of you have used a shovel or have taken a nail out with a hammer. You were using a third class lever. Okay, those are the 3 machines I wanted to go over today. As I said, next week we will cover screws, wedges, and wheel and axles. What you're going to be doing now is going to work on your worksheet. Just do the parts that we covered today.